We've talked about the similarities between alkynes and alkenes, but there's one really important difference. Alkynes are much more acidic than alkanes or alkenes. So, for instance, if I treat any alkynes have a pKa around 25 or so. Let's say I treat that with a very strong base. So this is called N-butyl lithium. We'll talk about sort of alkyl metal compounds like this next week. But for now, we can almost think about this as C minus Li plus. So this is a full-on conjugate base, sort of butane, the alkane. The pKa for an alkane is something like 45. And the pKa for an alkene isn't much lower. It's still in the high 30s, low 40s. So it's really functionally not acidic at all. So again, if we consider this an equilibrium, it's not much of an equilibrium, but there's 20 orders of magnitude difference in the acidity. So if I treat this alkyne with butyl lithium, I'm going to fully deprotonate my alkyne and get this, what I'll call a lithium acetylide. Acetylide is the conjugate base of an alkyne. These are good bases. Again, the pKa for the conjugate acid of this is pretty high. So this is a strong base with a very weak, not very weak, pretty weak conjugate acid. So it's still a good base, but it's also a good nucleophile. Remember our quadrant, basicity versus nucleophilicity. I said that when charge is concentrated on a small atom, that's usually a good base and a good nucleophile. This is a great example of that. All right? Remember, at least oxygen minus can hold charge better than carbon minus. Carbon, even sp carbon, really does not want to hold a negative charge. This is going to be a good base and a good nucleophile. How might we use this? Well, let's react that with, say, an epoxide. All right, so for instance, we've talked about backside attack on epoxides, a nice SN2 reaction. Here we go. Here's my nucleophile. Going to attack, pop the ring open. 2 carbons on the end here, sure, okay. Like that. Again, trans relationship when I attack an epoxide between the O and the nucleophile that comes up. This is a really good reaction to know because it makes a carbon-carbon bond. As you may have picked up, that's kind of a big thing in organic chemistry, right? Any big molecule of any kind of complexity that we might care about for any kind of purpose really is made of carbon-carbon bonds mostly. So this is a great example of getting a carbon nucleophile and able to make a carbon-carbon bond. Very cool. So alkynes, for the most part, we're going to just think of them as 2 pi bonds instead of 1 pi bond. So they're going to react much like other pi nucleophiles, like alkenes will, which is to say they'll react like alkenes. But one important thing that alkynes can do that alkenes can't is be deprotonated effectively to get acetylides, which are fantastic nucleophiles. Very good at doing SN2 reactions, particularly for epoxides.